Hey everyone, this is another clock radio video, and I'll tell you right now, I don't really do clocks, and this is my second one in as many months, but this one is special. This is one that my mother had in the late 60s, early 70s, and she saw this one, and they're like hen's teeth. It's an old Sony, and the guy who boxed this like a sadist. So while I unpack it, I'll tell you, they're like impossible to find, and the condition of this one, obviously if you're watching the video, it didn't just work out of the box. So I'm gonna get this one restored, and then I'm gonna ship it out to my mom because she wants to have it. So we're gonna get this going. Let's get started. I'm very happy to see that the veneer is in excellent condition. This time we'll just clean it carnauba and call it a day with that. So very nice indeed. All around, no chips, no cracks. Looking at the front plastic face is a good condition. Little bit of wear on the white perimeter, and we see that this knob is missing. We're gonna have to replace this knob. Other than that, cosmetically, no worries at all. Cosmetic is very hard to fix on these, so we dodged that bullet except for the knob. That screw doesn't look right. Already I'm thinking somebody's been in here. The boilerplates on the bottom of the unit, we could see that it's a 6 transistor unit, model 6RC-23, made in Tokyo, Japan. More evidence that this was messed with. We can see that the front bezel is actually on upside down, so somebody's been in this clock, didn't even assemble this correctly. The threads of this screw doesn't feel like it's pulling against anything, like it's the wrong screw. It is just a single screw that uses plastic tabs on the bottom to hold that cover on. Found the power cable stress relief floating around inside the box. The front bezel looks to be snap-on. I'm going to use a small screwdriver to carefully remove it now. So I got the bottom removed, now the top's removed, and gently take it off. No problem at all. So we can just flip it over so it's facing right side up. Want to test out the time adjustment mechanisms right quick. This is the alarm. That's working just fine. And now the time itself. The mechanism seems to be working okay. This is good. This is the on-off and alarm switch. This itself works, though we're going to have to fix the end dial for this. So now I'll carefully press the plastic bezel back in the correct direction, snapping it into place, and we'll have a look. That was an easy fix. Nothing inside looks like it was on fire, yet somebody extremely incompetent took it apart. There's got to be another gremlin in here. So let's plug it in and see what we get on the isolation transformer. You can hear the tap radiate into the speakers as I try and get the clock to work. Honestly, at this moment, I'm more concerned with the clock than the radio, because I think the radio is an easy fix. We're going to have to tear into this unit. These two screws right here hold in the transformer. They had completely rusted or chemically welded to the nut inside. They are most likely dissimilar metals, so it was lots of fun getting these out. And the heads of the screws are really cheap metal, so they are quickly destroyed. I couldn't get any power tools on there, so I had to use small pliers to remove them. I'll find a suitable replacement for these. These are garbage. The unit is then turned on its side to remove the volume knob as well as the tuning dial, and these two knobs come out without any issue. Those knobs will be cleaned separately. Now I'm able to pull out the transformer and the radio internals. They slide out on this circuit board. There's a piece of tape over here connecting the speaker wire, and on this side is a speaker. This slides out too on another board. So circuit board slides right out. So here we have pretty much everything except for the clock itself. And that's back here. We'll have to remove the front bezel to remove the hands before we can remove the clock mechanism. Carefully pry off each hand with a set of small flat heads, being careful not to damage them. Just let them fly up in the air and then put them to the side. Two screws secure the mechanism into the housing. There's a large metal plate that covers the whole unit, and that comes out first. After that, the rest of the clock mechanism comes out. We have our first date code, the 47th week of 1967. I'm going to disconnect the motor now from the clockwork with these two flathead screws. Now I'm going to isolate one half of this motor so I can take a reading. Set up a simple continuity test across both pins of the motor, and we see that it's open. Clip off the last two connections for a closer inspection of the motor. As I look over here, I don't see anything burnt or anything like that. I wouldn't expect it for really low current, but I got a good feeling that our bull in the China shop who worked on this last probably broke the connections right to the end. So I'm going to peel off this outer layer and have a look. If not, I'm probably going to have to rewind this whole thing because I can't go out and buy this motor. So I might as well see if I get lucky. Sure enough, this one contact was delaminated and this wire was broken off this pin. It's thinner than a hair. So I'm going to have to repair this. This was probably the cause. The wire was scraped to have the lacquer removed, and a very heavy flux is applied to everything. And with that, we'll solder the connection back together. We can retest it, and hopefully that'll do it. We're looking at 800 ohms. We may be back in business. And the motor does, in fact, turn. I read on the side, I think it's like 3.2 RPM. So it's kind of hard to see, so I'm going to speed it up on the camera. Better yet, we'll drop the motor back into the clockwork, which I've checked. There's no binding in that. We'll secure it down. Then we'll put the second hand on and check the functionality. And as we apply power, we can see that the second hand is working just fine. And this is great because this is one of the toughest things to fix or find replacement parts for. We can now move on to the next problem. Went to a hobby store and picked up some white paint, some fine brushes, and a perfectly sized marker. We'll cut off the damaged and fatigued areas of the old knob where the old knob had broken off so we could use the remainder to mount the new knob onto, leaving us with a stable working base. Now it's a lot more rigid. I can move it to the 3 positions without any worry of any further damage to it. Here's the marker that I purchased at the store. We'll remove it from the packaging and we'll have a look specifically at the cap from the marker to pair it up. We have some sizing to do. Looks like we also have some machining to do as well. No problem. But it looks like it's going to be a good fit. At this point, we're ready to move to a finer grit as we're almost there. And then polishing paste. Part's completed, it's shined up again. Looks real nice, it looks like an original knob. It's not knurled like the other one is, but I don't know if the original was knurled. I think it was, doesn't matter. And we can see that it passes through now, so the fitment is good. We're going to continue on to sizing. Looking at this knob and taking a measurement, and we're looking at pretty much 1 1/4 inches, and that's going to be the outmost measurement of the other knob. So I'll scribe that, and then we'll cut to size, and that looks about right. These pieces will need to be worked so it'll fit on top of here. This side will see the surface roughed up for better adhesion. Also, the top corners are slightly chamfered for easier fitment. Graduated unit bit was heated and used as a reamer in order to deform the plastic. I didn't record that for some reason, so I'm just demonstrating how that worked. Under heat, would remove some material as well as just stretch out the bottom so it would fit over the connection on the clock. Mating surface is cleaned with 99% isopropyl alcohol, as well as the surface inside the cap. Push some cotton down here in case I have a problem with the epoxy. I don't want it getting inside the mechanics, so I'm blocking it off. Now I'll mix up some 2-part epoxy, and this is going to go inside the cap, almost completely filled once we're done. Not only do I want the epoxy to bond the 2 sections together, I want it to provide internal rigidity to this cap since it's essentially hollow. Some epoxy will also be put on this mating surface on the outer portion, as well as on the inside where I've put that cotton to provide extra rigidity in this area. The 2 pieces are pressed into position. The switch is currently in the middle position, and the detent that I've put in this new cap is pointing upwards. Later, I'll paint that detent as a indicator for the position of the switch. Very little epoxy came out the top, but I'll be sure to wipe any excess away. A few hours later, test fit the front plate. Everything's looking real good. Very happy with the way this is coming out. Now I need to very carefully clean up the contacts that were used by the wires on the coil, being careful not to damage any of the connections that I've just previously fixed. At which point I could solder on the wires I had previously clipped off back onto those connections. Then I need to start carefully negotiating everything in the correct order back into this very small chassis without breaking anything. I quickly throw in the seconds hand and take a moment to evaluate, make sure the mechanics are working properly. I'll start tightening in the first screws up top. Then I have this metal shield to install. The shield is held in by 2 screws on the bottom, kind of difficult to reach. I need to remount this particle board, make it a bit wider for the new screws that I'm going to be using for the replacements to hold in the transformer. And we can see now a little adjustment lets it fit. Drop everything into place, bring it into position, turn it on its side, and run the first screw through. And then the second screw. Transformer is now in solid. Everything's looking real nice. Just need to address the stress relief right here. Curl the power cable back to its original position. Put the stress relief back in. Screwed it down. I'm going to refocus my attention to that volume pot. I know it's an issue. So I'm going to put the volume knob back on temporarily. Just going to hit this with a couple sprays of deoxit. And work the knob a couple of times. Then I'm going to spray it a couple more times. Work it a little bit more. Then we'll test it out. Looks like the deoxit was an easy fix for the volume knob. I know that we still have an issue with the tuning knob. Now we'll take a closer look at that. It tunes, but it looks like the shaft is broken, causing the capacitor to easily short out. It's not viable and it can't be repaired. It's going to have to be replaced. I found a tuning capacitor to the exact specifications. We'll install it when it arrives. I want to get these 2 pieces cleaned and the front face reassembled because all the parts are really fragile. So I can get about 50 years of Marlboros removed from this. All the tar comes right off, shines right up. Same thing for the front cover. Has it somewhat worse. Also looks like some Coca-Cola spilled on here at some point. Again, shines right up like new. No problem at all. Everything then dried out and buffed to a shine. So first I drop on the faceplate. Now I'm rotating the alarm time to the moment that it clicks on. With the alarm position known, I'm going to put on the alarm needle first and point it towards the 12 o'clock position. Only pushing from the center with my 2 nails to lock it into place. And just recheck it. This will be followed by the hour hand, which will lay over that one into the next notch, also in the 12 o'clock position. Knowing that the alarm is set to turn on at 12, it's set for 12, and it clicked at 12. The minute hand is then aligned for the 0-minute position, matching the hour hand at the 12 o'clock position, matching the alarm at the 12 o'clock position, matching the click. Finally, the second hand is introduced up top at the 0-second position over the minute hand position. We see everything lined up nice. An inspection sped up shows the mechanism of the clock is in good working order. I've set the alarm for 4 and I've turned it on to confirm that the alarm turns on at the proper time. So I'm going to adjust the time on the clock to see exactly when it switches on. And we're now sitting at about 3:30. I'm moving past 3:30 now to 3:45. And there, right at 4 o'clock, the alarm turned on. The calibration is good. Using the white paint that I had purchased, the outer perimeter of the bezel is very carefully painted. Once complete, it's set off to dry. Still waiting for my capacitor to arrive. I continue to work on the outer shell, cleaning it now, getting all the tar off from the Marlboros once more. And now I'm coating it with carnauba wax. So I'm just waxing it like a car, really. And then once I get a haze, I'm just going to remove the excess wax with a paper towel. It leaves for a nice shine and protection on the veneer. I think it's not too bad. Do the sides too as well. I'm going to come back to that front bezel. I've taped it up, and I'm using sandpaper just to clean it up a bit, any overpaint to square it off. I'm going to place that bezel back into the clock now, permanently I hope, and snap it back into place. And that's it for clock and cosmetics. We just need to finish the radio now. The new capacitors have finally arrived, so I'll remove that tuning knob. Take note of these two wires that connect to the capacitor. So I'll be heating up the pads now to remove those small wires one at a time. It's the first one, and here's the second one. Now I'm going to heat up the pads to remove the capacitor connections one at a time. And now I'll use a solder sucker to remove any of the residual solder left on those pads. I'll clean up the pins a bit so they fit through the holes. And this is everything all prepped for removal. Taking out the left screw first. I know the right one is stripped. I don't yet know why. I turn the right one and it just kind of does nothing. But I'm going to pull and pop the thing off. And there's a screw still in there. And this thing is cracked in half. This thing was in a bad way. I'm surprised it worked at all. And I can see the mount from the unit is still stuck in there. So I'll hold it with a pair of pliers to remove the screw. And it is deinstalled. And here is its replacement. The unit is seated in as to not bend any pins, making sure everything lines up. I check the holes for the screws and the pins on the other side. Then I put in the first screw, followed by the screw on the other side. Push these wires out of the way for the first connection as I bend the tab forward onto the pad. The second pad is prepped and the corresponding wire is pushed under the folded pad. The third pad is done with the wire in the same procedure. Finally, the knob is put back on for testing. The tuning knob is now working correctly as expected. There's no more noise. The volume knob was previously fixed, so both are working fine. It is, however, off tune. It's off frequency from the indication dial, so we're going to have to hit that next. I've got a loosely coupled antenna set up on my RF generator here, set up to about 540 kilohertz on the dial. Set the knob here for the bottom of the band, 540, and we're going to tune it in. Now it's on frequency. I'm going to move the dial to the top of the band. I got this set just past 1.6 megahertz. And we can see at the top end of the dial is within a reasonable calibration for this level of dial accuracy. Verify here with a midpoint reading of 800 kilohertz. We'll go down to the dial and check it around 800 here. And that seems good enough. We'll consider that the dial is calibrated. I'm going to switch it back to the IF frequency just for a minute and see if I could peak those. So I checked these two IF coils. There's no major adjustment that was required. Probably a very slight adjustment based on the age of the components in the unit. And so I'll remove the knobs, slide the radio board back in, as well as the speaker. Packed up the radio in the car. We're taking it to Ace to get the remaining screws that we're missing. Here I have a 3mm 0.5 by 5 for the back plate with a washer, 3mm 0.5 by 20 for the cable tension, along with a nut. So now I'm going to put in that second screw for the stress relief of the power cable and tighten it down. There was a piece of tape here to hold the speaker wire away from the transformer, so I'll add that now. The back cover was cleaned as to not damage the UL sticker. I put the back cover back on and fastened it in with the 3mm screw I purchased. Both the volume and tuning knobs were cleaned. and reinstalled back onto the radio as the last two pieces of this build. Well, that concludes this restoration. I hope you enjoyed this video on the repair of this Sony 6RC-23 from around 1967. I hope you found it informative and entertaining. Should you ever come across a radio like this, you know how to fix some of the idiosyncrasies of this unit. Do me a favor, hit that like button down below. Helps me out a lot when you do. Hit that subscribe button for more videos when they come out. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?